All right. So this was a fun week for us. We released 128 with basic simulate in it. We are currently missing some of the hashes, in my understanding, and we are missing the interesting issue that Kilari found on when contract is terminated. We need and it sends gas or is to somebody. We have not tracked that yet, so we are currently on it. Also, we are on the full transactions to make them show in the more complete view, and also currently I'm finalizing the integration of simulate primitives into the if call and suite of three other calls related to it. So that's it with us. I know that there was some nice discussion this week on the chat. Maybe we'll get to it after the updates.
Yeah, hello, I can go. So I was, let's see, we started the week with some CI problems. So I was looking into that and generally making sure that the test effort is going forward. And I think there was also, we found one issue. It was the default timestamp in Geth that I fixed. And yeah, one of my teammates has reviewed the PR, left extensive comments. So I just half an hour ago finished addressing all of the comments, and one of them turned out to be kind of interesting. And this is what we discussed on Friday. And maybe I will just talk about it shortly for Oleg's benefit.
Yeah, please do, so that everybody who watches on demand would also know
Okay.
what's happening.
Yeah, cool. So basically what happened was, so we have the state overrides for every block. And when overriding an account, you can also specify, if it's a precompile address, then you can specify that this precompile should be moved to another address. Now, what we had an account for in the Geth implementation was that because the state overrides is a associative array, like it's a dictionary, so the keys are not ordered. And there can be some edge cases where like you specify, let's say you say that account 1, which is the first precompile, should be moved to account 2, and then you later on say, okay, account 2 should be moved to account 3. Now, depending on the order of how, depending on which order Geth sees these overrides and tries to execute them, you will get different results. In one, there will be an error, and in the other one, the precompile would actually move in the correct order. So after some discussion, basically it came down to adding some restriction to the move precompile to feature, and that is that basically if you have moved a precompile that makes the destination address dirty, in the sense that that address cannot be overridden anymore. And that should fix the error. And I think sorry, I see somebody's hand raised up. Yeah.
Yep.
Oleg?
So my question would be, say you want to do a basic swap. You want to move 1 to 2 and 2 to 1. So how do we go about that?
Not allowed. You get an error. The idea being that there's not really any good reason to do a swap of a precompile. It doesn't really make sense, and it adds complexity to the implementation to support it. So it's easier to just say, swapping not allowed. Does that seem reasonable to everybody?
I think Nethermind allows this overriding and moving all the contracts. And I guess there it might be more useful to use case, but not for pre-compile. But the spec is only for pre-compile as well.
Even for overriding contracts, I feel like a swap is unnecessary. You can always just move 2 to 5 and 3 to 7, and just, or I can't. I struggle to think of an example where you'd want to do a swap. Like you can just put new code on the chain using a state override.
Yep.
Yeah, with contracts you can replace the code better, but yeah, with precompiles you cannot do that.
Right, but like, why would you want to replace like one math function with another math function? Like that doesn't make any sense. Or like, ECDSA, replace it with I don't know, Groth 16 or whatever people are using these days. Like it's a kind of a nonsensical operation.
Well, basically, it can be a test of stability of implementation. Basically, you have implementation A, you had implementation B, you compare how they are going around the tests. So, but yeah, that is like stretched out case.
Yeah. Does anyone want to defend that use case strongly? Again, the worry here is that it adds significant complexity to guess implementation at least. And I would assume similarly in Nethermind, because JSON objects are not ordered. And so you guys probably have the same kind of fundamental problem where you have to like turn it into an ordered list first or something.
Yeah.
Okay, so let's just
All
say...
right. So basic idea is that we flag addresses as dirty as soon as they're used, and we allow them to be used only once here.
Yeah, you can move from a clean address to any other address. Any address you move something to is considered dirty. Any address you move something from is considered dirty after the move.
The address I'm moving to shall be clean or shall be dirty?
Dirty.
Or can be dirty?
It'll become dirty by moving to it.
Can it be dirty when I'm moving into it?
No, also not.
Yeah.
So basically, you can touch each address one time in the entire override section.
Yes, Lucas, please.
What's the problem? Is that when we have multiple overrides on same addresses? Kind of?
Yeah, multiple overrides that... so you override 2 by saying, I want to move the content of precompile at address 2 to address 3. And then later on, you say, okay, I want to move the content of address 3 to address 4. Depending on the order you execute those two operations, you get a different result.
Yeah, I get it.
But
I get it.
The object's unordered.
To be honest, I would just say that if you do this, there's like the order is not guaranteed, and that's it. Because I don't see any like real use case to do this.
Yeah, agreed. And so the question is so we can say the order is not guaranteed, but like in the case of Geth, it's a difference of one of the operations will succeed, the other one will actually give you an error and fail. And so they'd have to write extra code to make the second one actually work at all. Like one of those orders just doesn't work in the way they've implemented it. And so
the second thing is just order it by address before we apply all the overrides.
Yeah, that would be the other option. Though actually, would that solve your problem, Sina, or would you still run into problems?
It's yeah, that would also solve. That's the alternative. I think I slightly prefer the restriction to have just to allow once an address to be touched. But I'm also easily convinced to go for the ordering, like that we define one order and go with it. I do find that there's not a real, I couldn't think of any use case for wanting to do any of these things, so the error should not matter to the user, and the ordering, I just don't think that it should be order dependent at all,
I tend to agree, and if we did decide to go order dependent, though, we would have to define what the expected behavior is if you did 1 to 2 and then 3 to 1, let's say. what is that behavior? Do we assume that, or let's say you go, maybe a better example, let's say you go, that works, yeah. So let's say, you sort them by address and you move whatever's at 1 to address 2. And then you say, take whatever's at address 2 and move it to 1. Does that take what was at address 2 before the override, or was it address 2 after the override, or does it result in an error?
It is linear, so it will take whatever is in 2 and place it into 1. So it's like a simple instruction set that is ordered by the number of the what we are moving. And yeah, it's currently what is implemented at Netmind, because we pass whatever is given to us by a user into an ordered dictionary, basically, that is sorted by the key. So it is exactly what we are currently like. What is the option B?
So just to confirm, then you're not able to perform the swap also, because if you move 1 to 2, that means that there's one has overridden 2. So when you move 2 to 1, then already the first precompile is being moved to 1. So both, 2 is going to be cleared. There will be nothing in it. Well, there will be the EVM code that you're supposed to also put in the override. And 1 will have the same precompile as before.
It seems to me that there is a simple solution of doing just a swap instead of just moving. So if you swap, then there is always something somewhere and everywhere.
Okay, we can also change the algorithm to firstly read all the things that will be moved, store it into some temporary thing, and then just move it to the thing it will be moved to. So if the swap would just work then.
Yeah, my instinct is that's a lot of complexity for a use case that none of us can think of a legitimate use for.
So my question to Sina would be, if you always execute the swap instead of just move, would it solve the issue?
I'm not sure I understand. What do you mean?
You'd have to
Like
do
we
what
change the move operation to a swap operation?
Yeah, we
or-
don't want to do that probably.
You basically have to go through and you do 2 passes. First pass where you look at all the things that are being moved from. You save what's currently there up in some temporary location. And then you do the second pass where you look, okay, what is going into each of the locations? And then you can then pull from the original code. It's more complex, and I would argue against it because we can't. It's not for a good reason.
Okay, I'm actually fine with it. It's a very simple solution, and
With the swapping, you think it's simple?
yeah, it's not that hard. You just introduce one intermediate collection to.
So we would need to add the swapping and the ordering, right? Because
No, order doesn't matter, or does it?
yeah, I think it does.
So if you go 1 to 2 and then 2 to 1, that 2 to 1 is actually taking the original 2, not the overridden 2.
Yes. So order doesn't matter because we always will take the original or as original as possible.
Is it a DDoS vector?
No.
Yeah, but you also have to consider that when we do the 1 to 2, 1 can be overridden with EVM contract and 2 can be also overridden with EVM contract. There's also the semantic of whether something is a precompile at the end of this override procedure or not. That we also have to determine. So if you first do the 1 to 2 move, that means that 1 is not a precompile anymore and 2 is now a precompile. And so if you do it in the other order, when you move 2 to 1 first, then 2 is not a precompile anymore and 1 is. So I think, there's something that we also. So I think what we need to do is to take swap and ordering into account both, and then this would work.
I don't follow. Right? If you move 1 to 2 and 2 to 1, if you firstly take the original values of 1 and 2 and store it, and then apply the move from this and not the temporary swaps, then I don't get it. Why is it a problem?
So the example that, okay, maybe it doesn't demonstrate in this example, but there's if you move 1 to 2, and then you want to move 2 to 3.
Mm-hmm.
And so that means that 2 has been overridden.
Yeah, but you're not. I think you're not using the algorithm I told about. So firstly, store all the froms. So if you move 1 to 2 and 2 to 3, then you store 1 and 2 temporarily at your what you're moving, and then you do the pass. So if you move 1 to 2, you move the original 1, and then you move 2 to 3, you move the original 2, not the overridden 2.
Yeah, basically you store everything that is addressed in a buffer, and then you move copies.
Yeah, kind of. So you move from you store the original values of everything you will be moving, and then you use those for moving, and not the things that could potentially be already overridden.
Let's just look outside the algorithm. Let's say like black box. What should happen when I do 1 to 2 and 2 to 3? And I'm not saying only
original one moves. So at the 3 we'll have what you had at 2 before any move.
3 should have
original 2.
Original 2. So the second precompile.
Yeah.
And what about 2?
2 should have the what was originally at 1.
But it's also being overridden with EVM code.
Oh, I see. The issue here is that when you do a move, you leave something behind with the move. I forgot about that. So it's not just you move 2 to 3. You're moving 2 to 3, and then you're putting that same operation is dropping something in 2. Like you're moving 2 out of the way, so you can replace 2 with some EVM code that you supplied. These are supplied. And so if you moved 1 to 2, that means that we want 2 to contain whatever used to be in 1. But then the user also said move 2 to 3 and leave this in address 2. And so we have 2 conflicting things that both want to be in address 2. The thing that used to be at 1 and the thing the EVM code the user supplied in the 2 to 3 override.
Okay, let's just throw an error then.
Okay. Yeah, I totally forgot that we have that EVM code that gets left behind. It's not just a simple move. Okay, so if I understand correctly, the consensus is you can touch a given address one time in the overrides, either as a source or as a destination, doesn't matter which, but only one time. If you touch any address twice, we just throw an error. We say bad parameters or whatever. So if you do 1 to 2 and 2 to 3, you're touching the 2 address twice, so it's an error. If you do 1 to 2 and 3 to 2, also an error because you're touching the address 2 twice. Is that align with everybody?
Yeah, all right.
Okay.
I think one big project still ahead is getting the hashes to match between Nethermind and Geth.
Yeah, by the way, could you send to me in a DM or something the spec for the full transactions that we shall have?
The full transaction flag?
Yeah, basically to what shall be changed in the return stuff.
Yeah, I think it's the spec, but yeah, I can share it.
Yeah, please do.
Yeah, and I guess getting those transaction hashes to match is the first thing we should do, and then see if those fixes again the issue, and if not, then we need to look more carefully why they're differing. I don't think I don't have any test cases where the hashes would be the same between the clients.
Do our current hashes match if you send blocks without transactions?
Oh, that's a good question.
I don't think it matches.
No transactions, no overrides, just blank blocks.
Yeah, blank blocks.
Okay, we can find out easily.
They don't match. The hash is different.
Okay, we should probably troubleshoot that one first. Maybe it'll solve all of them.
Yeah, so full transactions won't help you a bit as long as the basic blocks are different.
Well, it's about all the values are going to default, and then it's about if the default values are the same.
Do you guys do both clients have an easy way of just exporting what the object that you're hashing is, perhaps after RLP encoding, or before, either one. Like the actual thing that you're encoding to hash. You have like an easy way to just export that for one test.
I don't really think so. But we
Or even
can
just
do
print
more
it out.
logs.
Yeah, log it out, something. Just so we can just get the RLP object or the pre-RLP version of that same object. Either one would be fine, I think. We can just compare, and they should be obvious where the difference is at that point.
Yeah, so what we can do is maybe temporarily add the full object as a field in the API and then remove it or before the PR is merged. It's a dirty hack, but
So my question would be, what are the fields that we are currently not printing out about the block? We know basically that the issue is inside the block difference. So there is a lot of information that we print about every block, just like in vanilla simulate. So the question would be, what fields don't we print out? And if every other field that we print out is the same,
the size is different. The size and hashes are different. But yeah, with the size is also hard to say why it's different.
And this is the only difference, yeah? Fun.
The only difference in the blocks here.
Mm-hmm. Quite fun.
So I would say just if each client can just simply do an log out just the RLP encoded block, you can then just diff the two, and you'll see where the difference at.
mm.
Yeah, I don't think we even need an API for it. Just log it from your client.
I'm wondering if the size refers to the full block or just the header.
The header is what's hashed, right? Body's not hashed.
Mm-hmm.
So if the size matters, then it's going to be the header size. And there's only a few fields that can vary in size in the header.
Do we print out metadata? We do,
What
right?
do you mean by metadata?
The special field that every client can set with basically text, like this block.
Oh, the extra data?
Yeah.
Yeah, that's not returned. But is the default for those different?
It may be.
Mm-hmm.
At least in our production client, definitely is. Because we
I would
have,
assume it's empty.
no, we would have a default like built by Nethermind or something like that.
Mm. I think I'm not setting any value for that. So if Nethermind has a default, that could explain.
Yeah, let's should we just define that as empty byte array?
Yeah, basically the question is, are there any other like such fields that we may be missing?
Certainly seems like the most likely one.
Yeah, and it would affect the size probably.
There's the block author fields, right? I think there's still a block author field. That may be something that you guys default differently. One of those fields that will break a hash but isn't likely to be overridden or set by anybody explicitly.
Yeah, we'll check the defaults that we have. Maybe if so, there is a nice page that is the markdown page that we have on Simulate. Maybe we could like check if it has complete defaults, so that we'll be sure that we have something to compare to.
Yeah, that's a good idea. We can probably take care of that, Kilara, you think? Just basically make sure that the specs page or the markdown associated with it has a full block header, including all of the defaults for every field that has defaults.
Yeah, it should have all, but yeah, I didn't know about that extra data that's probably not there.
We should. I'll give you a link on the official docs for the block header. We should make sure everything's in there.
Okay. But like that extra data is not something that when you are getting blocked, then I don't think it's a returned.
It may not be returned by get block, but it is part of the header. And the thing we care about here is the actual header itself.
Well, before we have been caring what the get blocked by number is returning, and it's not there. I think. I don't know why it's not returned the block by number. Oh, there's extra data in the block, and we are not returning it. No, we are returning extra data, so it's there. And I think both are returning it as empty.
Mm-hmm.
Yeah, we are both are returning it as empty. Yeah.
So they differ by size, but by nothing visible.
Yeah.
And the size itself is not part of the hash, so. But it's a clue. Maybe we can check
You need
why.
to peek under the hood.
Yeah.
But something that is hashed, then if its size varies, then it also changes the hash.
Yeah, so that limits it to the integer fields and the bytes field. Everything else is fixed size. So in that link I just sent, the uints, the u256, and the bytes. That's extra data, timestamp, gas limit, gas used, number, and difficulty. And blob gas used and extra blob gas.
One explanation can also be that the client is lying and it's returning something else than it's actually hashing. So that something is hashed, but it's not returned as the same. But I don't know. I don't know the client's code if that's possible.
Hopefully not.
Because that has been the case before, that some gas used values were differing in what was returned and what when you sum out all the gas used together, it didn't match up to the block gas used. So Nethermind used to have that kind of bug. So I wonder if that kind of issue could be there. Would it be difficult that you would get all the feeds that the multicall is returning, and then you would calculate it outside what the hash of that block should be? Do we have all the information for that?
Maybe, how about this, Chloe? Can we, so we have Geth and Nethermind disagreeing. Can you this week generate a block and hash it using a third algorithm, like a JavaScript thing or something? And then see which,
we have all the data
client you match. Well, so if we don't, then we should, this exercise will answer that question. So you try to construct a block header following that link I just gave. Just make sure you fill it in, RLP encode it, and then hash it, and see if you match Nethermind, or see if you match Geth, or see if you match neither, or see if you don't have enough information to actually fill it in.
And can we, by the way, like fill as much as possible of the same block in a plain like is simulate call? So basically to have an is simulate call that fills in, like explicitly sets everything to be whatever we want, or we are limited in that regards.
That's a good idea. We should have, so there's two test cases that I think are good for debugging this. One is a test case of a block with no transactions, no overrides, nothing, right? And then another one, which is a test case where you have a block that overrides literally everything to very explicit values. And so we might see agreement on the latter, but not on the former, for example. So those would be both very good test cases. Mm-hmm. But in that second one, don't include transactions or overrides still. Just fill in fields.
Yeah, just plain empty block.
And I don't think we can override everything. So there can be still something that we cannot override. And then with Nethermind, there's a bug that you cannot override the timestamp, for example.
Yeah, we'll fix that.
We should override as much as we can, and then compare those and see if because that'll help us narrow down which fields might be the difference. Since it seems like it's going to be challenged to get RLP encoded blocks from the clients.
yeah, it would be nicer to get what is being hashed and then get that printed out, and then you know right away.
Yeah, we would also, if we could have a page where we would have this like hashes to compare to or compare against, that would be perfect.
Yeah, I can try to do some test cases to calculate those.
I think I have some code lying around somewhere that's will hash a block.
Do you have anything else?
No, probably not. All right, thank you all for coming, and I'll see you all next week. Thank you
See
all.
ya.
Bye.
Next week.
Thank you. Yeah, guys.
Bye.